Okay, so in class we did up to example 3, so now let's look at example 4. Here we're being asked to multiply 3 binomials. So basically if you were to set that up in a horizontal format, that's x minus 1 times x plus 4 times x plus 5, and you want to multiply them one at a time. So let's just look at a numerical problem that's similar. There's no distribution that's happening in this example. All you do is multiply 3 and 4 and get 12, and then 2 and 12 to get 24. Or you could have multiplied 2 and 3 to get 6, 6 and 4, 24. Or you could have done 2 and 4 to get 8, 8 and 3, 24. Notice, whichever way we choose to multiply it, we get the same number regardless. So what that means is I can rearrange this however I want and still get the same answer, but it doesn't really matter. I'm just going to leave it as is and multiply these two first. So when you multiply that out, you get x squared plus 3x minus 4, and you still have to multiply that by x plus 5. I would take that x plus 5 and move it to the front because I just think it looks nicer that way. And then I would continue multiplying by either distributing or doing the area model. Me personally, I like the area model, so I'm going to do that. Remember, that means we have 2 rows for the 2 factors in the first parentheses and 3 columns for the 3 factors in the second parentheses. Sorry, for the 3 terms in the second parentheses. And now I'm just doing area. So x squared times x gives me x cubed, 3x times x, 3x squared, negative 4 times x, negative 4x, and so on. Whoops. Now, of course, you don't have to use this method. I'm only doing it because I like that the like terms line up on the diagonal. So then the final answer here would be x cubed plus 8x squared plus 11x minus 20. All right. These special products are good to know because knowing them will help us learn how to factor. If you have the difference of 2 perfect squares, that can be factored into the square root of a plus or minus the square root of b, okay? Which means when I am going the opposite direction and multiplying this out, I don't have to do every single part of the distribution process. If I'm doing FOIL, I don't have to do outer and inner. I only have to do first and last because those middle terms are always going to cancel, which we've seen in problems similar to this. You FOIL and you get x squared minus 3x plus 3x minus 9, and those middle terms will always cancel out. That happens when the parentheses, the factored form, is literally the same, just opposite signs, okay? Some other important ones are the square of a binomial. So this is when the part in parentheses is literally the same. So a plus b times a plus b, or a minus b times a minus b. In which case, the first and last term are the quantity squared, so a squared and b squared. And then the middle term is just 2 times ab, okay? Again, you could always just multiply it out, like y plus 4 times y plus 4. We saw this when we did perfect square trinomials, right? The middle term is this number times 2, and the c value is this number squared, okay? Won't go into too much detail with that because we've already discussed it. For the cube of binomials, this is new, okay? Honestly, I don't really use this formula. I just actually multiply it out. So I just do m minus 2 times m minus 2 times m minus 2, and then simplify it in a similar fashion to this problem, okay? So that's all we'll talk about there. Let's move on. You can skip this one. Okay, here, because the parts in parentheses are literally the same except for the sign, this is where you don't have to do every part of the distribution process. You can just do first and last, okay? Because the middle terms are going to cancel out anyway. So 4n times 4n is 16n squared, negative 5 and positive 5, negative 25, and that's it, okay? If we were to do outer inner, notice you would get 20n and negative 20n, which cancels to 0. So what we're left with is the final product, okay? Moving on to B, this is 9y minus 2 squared, which is equivalent to 9y minus 2 times 9y minus 2. 9y and 9y give you 81y squared. Negative 2 and 9y give you negative 18y, and that will appear twice, which is why we could multiply by 2 to get the middle term, which I don't always do. And then combining these like terms, you would get 32y and plus 4. So that's the final answer there. Okay. Here, I could use the formula, but to be honest, I'm not a huge fan of it, so I literally just multiply it out. I find it easier than using the formula, me personally. So I'm just going to start by multiplying these two. So AB times AB is going to give us A squared, B squared. So that's first outer 4AB, inner 4AB, last 16. I still have AB plus 4 here. I'm going to combine my like terms here and get 8AB. So that's going to be AB plus 4 times A squared, B squared, plus 8AB plus 16. And now I have to distribute each term into the parentheses. Just to do something different, I won't use the area model. I'll just distribute each term into the parentheses. So that gives me, that first distribution gives me A cubed, B cubed, plus 8A squared, B squared, plus 16AB. The second distribution of 4 into each term, I'm going to line up underneath the like terms. So 4 times A squared, B squared is 4A squared, B squared. 4 times 8AB is going to give me 32AB, and then 4 times 16 is 24, 64. Okay? So then combining all my like terms, I should get A cubed, B cubed, plus 12A squared, B squared, plus 8, 4AB, plus 64. And that would be my final answer, okay? One thing to remember that maybe you were confused by is AB times AB is A times B times B if I rearrange it, which is A squared times B squared, right? If you have multiplication and the bases are the same, you just add the exponents, okay? So that's that. Now that was pretty long and tedious. What we're going to look at here is a unique way to multiply out binomials using Pascal's triangle that makes the process a little bit easier, especially as we get to powers that are really large, okay? So if you notice this triangle, let's just look at this triangle here. Each row comes from the previous row through addition, okay? So the first 2 rows always start with just 3 ones, but then each value underneath comes from combining the numbers above it. So what do I mean by that? First of all, 1 plus 1 gives me 2. 1 plus nothing gives me 1, okay? If we were to continue the process, 1 plus nothing gives me 1, but 1 plus 2 gives me 3, and 2 plus 1 also gives me 3. 1 plus nothing gives me 1, okay? Keep going. 1 plus nothing gives me 1. 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4, and so on. Okay, last row. 1 plus 4 gives me 5. 4 plus 6 gives me 10. 6 plus 4, 10 again. 4 plus 1, 5. Okay, let's do another row of the table using this understanding. Okay, so try it yourself. I'm going to do it now, but if you want, pause the video and try it. Okay, so 1 plus nothing is 1. And don't really have space for this. 1 plus 5 is 6. 6, 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1, 6. 1 plus nothing, 1. So that would be the next row of Pascal's triangle, and the pattern just continues from there. So 1 again, 1 plus 6, 7. 6 plus 5, 21. 15 plus 20, 35. 20 plus 15, 35. 15 and 6, 21. 6 and 1, 7. 1 plus nothing, 1. Okay? That's the idea. It's just a pattern of numbers, but the cool thing is that this pattern of numbers ends up being useful for us when it comes to multiplying out binomials, okay? And the best way to see it is with an example, okay? So, how this works. If we're multiplying out a binomial, we're going to take the first value in the term, and we're going to raise it to the largest power. Or sorry, not the largest power, but the power outside the parentheses. And then from there, we're going to keep decreasing that by 1 as we move to each term afterwards. Okay? So in this example, you started with a to the 5th, then the next term was a to the 4th, a to the 3rd, a to the 2nd. Right here, this is really a to the 1st. And then there's no a value here because the next one that would be in the pattern would be a to the 0, but anything to the 0 power is just 1, okay? So that's the first term in the parentheses. The second term in the parentheses, before we multiply it out, follows a similar pattern, except it goes in the opposite order. What does that mean? Instead of starting with 5, we would start with 0. I know I don't have space, but that's b to the 0. Then b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, and b to the 5th, okay? Let me just underline them instead. Okay? So that's what you do with the a and b values. And then if you notice, maybe you didn't, maybe you did, the coefficients, the numbers in front, this 1, 5, 10, 10, 5, 1, those coefficients come straight from Pascal's triangle. It comes from the 5th row of the triangle, which if you notice, the power we're raising this binomial to is the power of 5, okay? So it seems complicated, but it's all about the pattern. So just try and pay attention to the patterns, okay? So I'm going to reiterate it down here in these notes, how this works, okay? The first thing to note is that an expansion of the form a plus b to the power of n will have n plus 1 terms. So let's say, for example, if n is 10, then the expansion has 10 plus 1, 11 terms. And we can see that again in this example, because we have 1, 2, 3, 4, 5, 6 terms, and the power we were being raised to was 5, okay? Then you take the first term of the parentheses, in this case it would be a, and you start with the power of n, and then for each term you just decrease by 1, and so on. And then you take the second term of the parentheses and you do the same thing, but you start from the opposite end. So you start with b to the 0, then b to the 1st, then b to the 2nd, then b to the 3rd, b to the 4th, and so on. The final thing, oh, they don't say it here. I thought they were going to say something else, okay? Let's use something else. Use the nth row of Pascal's triangle to get the coefficients for each term. Okay, let's do this. Okay. So here you have x minus 5 to the power of 5. So let's do one thing at a time, okay? I know this will have 6 terms. That doesn't really help me write them, but just so I know I have 6 terms. I start with the first term in the expression, and I raise it to this power, and then decrease as I go. Leave space in between. So that's x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0 would come next and would be the last one, okay? Then I do the same thing with the second term in the parentheses, okay? But I do the opposite. So I'm going to do -2 to the 0, -2 to the 1st, -2 squared, -2 cubed, -2 to the 4th, and then -2 to the 5th, okay? So far I've taken care of 1 and 2. Now I just have to do this last part. So because it's being raised to the 5th power, I'm looking at the 5th row of the triangle, and I'm just going to add those values to each term in the order that they're written. So that means I have times 1 plus times 5 plus times 10 plus times 10. I did not give myself enough space. Plus times 5 plus times 1. Really losing space here. Oh my goodness. What a mess. Okay, now I just need to simplify, okay? So, -2 to the power of 0 is just 1. 1 times 1 is 1, so I just get x to the 5th. This is very colorful, okay? -2 to the 1st power is just -2. -2 times 5, -10, x to the 4th. Okay, next term, if I was to do -2 squared, I get 4. 4 times 10, 40, x cubed. Okay, -2 to the 3rd is going to be -8. -8 times +10, -80, x squared. -2 times 4, or sorry, -2 to the power of 4 is +16. 16 times 5 is 80. And then -2 to the 5th is -32. -32 times 1 is just -32. And x to the 0 is just 1, so that is my final answer. My goodness. Okay, now that seems like a lot, but the more you do it, the more you get used to the pattern and the quicker you're able to do it. And I think it's definitely way easier than multiplying this out horizontally or using the area model or whatever, okay? It might seem hard in the beginning, but it definitely gets easier. So let's just keep going. This one's a little bit easier because it's only being raised to the power of 3. Let's go ahead. All right, let me try and give myself more space this time. So 3y is my first term. I start off, remember, with the largest power, 3, and then I decrease from there. I'm giving myself a lot of space this time, just in case. Okay. Then I take my second number. Good thing it's a 1. And I do the same thing except in the opposite order. So 1 to the 0, 1 to the 1st, 1 to the 2nd, 1 to the 3rd. Okay, now for the last step, I go to the 3rd row of Pascal's triangle. 3rd row of Pascal's triangle is here. And by the way, we don't count this as a row. You might be wondering, isn't that the 4th row? But no, we don't count that. So that is the 3rd row, and it's 1, 3, 3, 1, which means I have 1, 3, 3, 1. Okay, now we just simplify. 1 to the 0 is just 1. 1 times 1 is 1. 3y cubed. Remember, 3y cubed is equivalent to 3y times 3y times 3y, or 3 cubed times y cubed. 3 cubed is 27, y cubed. Then you have 1 to the power of 1 here, which is 1. 1 times 3, so this is 3. But then 3 squared is equivalent, 3y squared is equivalent to 3 squared y squared. This is equivalent to 3 squared y squared. which is equivalent to 9y squared. So 9 times 3, 27y squared. Hopefully I didn't do that too quickly. Okay, 1 squared is 1. 1 times 3 is 3. So this whole thing simplifies to 3. 3y to the power of 1 is just 3y. So 3 times 3y is 9y. That simplifies to 1. 1 to the third is 1. So you have 1 times 1 times 1, which is just 1. And that's your final answer there. And that's it. Very good, guys. Okay?